Tracker 3 is the latest major release of our object tracking software. Previous users will see the same software interface, but a lot of work has been done to improve the quality and accuracy of data and how users are able to access this data, making this the most powerful iteration of Tracker thus far. One of the major highlights of Tracker 3 is its compatibility with new hardware, which includes the new line of Vantage cameras, the Lock Plus synchronization device, and the Vicon control app, which gives you remote control of your system. Please see their corresponding video for further information. In terms of performance, there are 3 points to highlight. Tracker 3 has been re-engineered to significantly reduce processing latency and improve processing frame rate, even with a higher number of tracker objects and cameras by making full use of modern multiple-core CPUs. In addition, jitter reduction algorithms use the higher quality grayscale data from the cameras to reduce noise in real-time data. Lastly, Tracker 3 introduces new filtering and smoothing options, including the ability to create your own and save them. It also allows you to apply different filter options to different objects. For the remainder of this video, I will focus on 4 new features and demonstrate the use of each. First, I will show the advanced options for setting the volume origin, which gives the user more control over the global reference frame. Next, I will look at how to enable track mode and discuss its benefits. Lastly, I will look at 2 different ways to access data: exporting directly to CSV and streaming to Simulink. For a more comprehensive list of what's new in Tracker, open the Help menu in the software and click on View Installed Help. Here you will find a list of new features for each point release, as well as documentation for how to actually use your system.
The first new feature that I will demonstrate are the advanced options for setting the volume origin. These are features that were actually released within Nexus 2 and have now made their way into the Tracker platform. So I can, as always, put the calibration wand down at a point and go ahead and click Start. It'll apply a model to that wand, and then based off of the orientation of that wand, determine my global coordinates. However, if I go ahead and click Show Advanced, I actually have more options available to me. The first one I'm going to actually talk about is going to be this 3 marker option. All right, so I'm actually going to click the markers first and then describe what it did after the fact. So I'll go ahead and click Set. It wants me to select an origin marker, then a primary axis marker, and then a secondary axis marker. So what it's done actually, and now if I actually zoom in on the origin, is the first marker is going to be that origin. The second marker that I've selected is actually going to be my x-axis. The third marker that I selected just needs to be in the general direction of the positive y-axis, as all it's really done is taken a cross product of that first x-axis and that vector between the origin and that third marker that was selected. So that would actually become my z-axis. Then it's going to do the z cross x-axis to give me that y-axis. All right, now with my axis actually defined, I can go ahead and move the axis to any of these markers that actually exist in my volume right now. So I could go ahead and just set the origin to this marker over here and see how it's shifted that entire axis to that one marker. So this can be very useful if you have an origin that you can't actually place the wand at reliably, but you still want it to be your global origin. Another option that you have is to actually manipulate the floor plane. Again, if you cannot lay the wand flat, you could actually lay a set of markers across your room, or if you think that your room is uneven, this may be something useful to you as well. And I can go ahead and hit Auto Detect. The only thing that I have is this option right next to it that will allow me to set the tolerance, so how close do these markers actually need to be in that plane to be a part of that floor plane. So I'm going to go ahead and Auto Detect. You can see it's selected markers that are on the floor that are part of that plane, and it's actually moved that XY plane for me. Another option is if my volume is actually below the surface or is above the surface, I can go ahead and select an offset as well. So just to make it really clear, I can go ahead and make this 200 as an example, and now if I auto detect, you can see that the floor plane has actually been shifted up 200 millimeters. So all these options just exist to give you more power so that you can set the origin in places where you wish to. The next feature that I will discuss is track mode. Track mode changes the state of the system so that it no longer displays nor streams any markers that are not associated with an object. So you can see I've got two objects here, object 1 and object 2. If I disable track mode, you can actually see that there are still markers present in the volume. The net effect of enabling track mode is that it will actually decrease latency, as it does not need to process any of these markers that are not tied to an object. In addition, what I can do is I can actually go ahead and disable objects so that, again, I can reduce latency as it's only tracking the one object that I want to track without having to physically remove that object from the volume. One thing that you do need to be wary of, and let me just delete this object real quick to show you, is that I won't be able to create any new objects with track mode enabled. So I'm going to go ahead and need to disable track mode to show any of those markers not associated with an object, and then go ahead and create my object like I normally would. So let's go ahead and put object 2 back in here and create, and then that will automatically enable track mode again. And as you can see, it's eliminated those markers not tied to an object. The next major feature that I will demonstrate is the ability to export a CSV file directly from Tracker. This is only possible, however, from an offline recording. So what I'm going to go ahead and do is I'm going to load a trial that I've already pre-recorded. It's going to take me to the default location for where trials are actually captured. This is going to be in Documents and Vicon Tracker 3.x, Captured Trials. I'm going to load in that Tracker 3.2 video that I already captured. You'll see that as soon as this happens, it'll take me offline. I'll get my play bar as normal. But you'll see that under this Export CSV heading, I've actually got a file name that's been input. And that's actually just going to be the name of the video with the file extension changed to .csv. You can see here I've also got different options for devices that I want to export, in this case none, and then which objects I actually want to export to the CSV as well. If I show advanced, I can set the current or the first and the last frame. I can also choose to put in all unlabeled trajectories as well. But I'm going to go ahead and click Start, but before I do, actually, let me just show you what was actually happening in this recorded trial. I'm going to go ahead and click Start. As soon as that's done, I'm going to go into the folder location. You can see that there's now a CSV in that same Captured Trials folder. Just go ahead and open that, and you can see that you got your 6 DOF for each object.
The last feature I'm going to demonstrate is the ability to stream data using the DataStream SDK directly into Simulink. So I've got the same trial here. You can see Tracker 3.2 video, the same 2 objects. I'm just going to make sure to press play so that the data is actually streaming. And then I'm going to open up MATLAB. I've already created my current folder, and I've done that through Documents, and I've created it as MATLAB Simulink. And I'm actually going to drag in files from 2 different locations. The first one is going to be from the DataStream SDK that should be pre-installed before trying to stream into Simulink. So I'm going to go ahead and drag in all the C++ files except for the compiled C++ code and just copy it into the current folder. I'm then going to go into the Simulink DataStream SDK multiple objects, because I've got 2. There's also a single object folder. And I'm going to go ahead and bring in the S function and the Simulink model. Next, I want to actually link the the S function to the DataStream SDK, and I can do so using the following command. Again, if you use a single object, this we'll just change the name of the S function here. When it's compiled, a new file will be created with a different extension. And then in order to actually just run the Simulink model, I'm just going to go ahead and drag in this MDL file. So I'll just drag that over from the other screen. And then I'm just going to go ahead and run it. It's going to compile, and then you'll see that the data starts streaming. This is just an example, so you can go ahead and add more Simulink blocks should you choose to.
Thank you for watching this video on the Tracker 3 new features. As always, if you have any questions about this video or your hardware or software, please do not hesitate to contact us at support@vicon.com. In addition, make sure to check our website and our YouTube playlists regularly for the newest updates and newest training videos. Thank you.